All right, hello everybody. Welcome to 5.5 Observational Studies and Experiments. Let's start with confounding. So confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So it occurs when two variables are, well, let me just use this. There we go. Associated in such a way that their effects on a response variable cannot be distinguished from one another. So a confounding variable is basically like if you're trying to measure, see if there's a correlation between A and B, like, doing this causes B to happen, sort of thing. A confounding variable is something that's kind of under the radar. That might be the real reason why A and B have a correlation. A might be correlated with B, but not because A has anything to do with it. Maybe something else that has something to do with it. Struggling to think of an example off the top of my head, but I know we have an example down below, so I'll talk more about it when we get to that example. The second part of this, experimental unit. Experimental unit, the object to which a treatment is randomly assigned. When the units are human beings, they're often called subjects. All right. Treatment, a specific condition applied to the individuals in a treatment. Placebo, a treatment that has no active ingredient, but is otherwise like other treatments. I'll talk more about placebo in a second. Control group, a group used to provide a baseline for comparing the effects of other treatments. Depending on the purpose of the experiment, a control group may be given an inactive treatment, an active treatment, or no treatment at all. We'll talk about that as well in a moment. Placebo effect describes the fact that some subjects in the experiment will respond favorably to any treatment, even in inactive treatment. So let me kind of go back to placebo, control group, and placebo effect for a second. So a placebo is like a fake pill, or a fake treatment. So like, let's say you're trying to do a study on whether a certain medication or a certain pill, like, I don't know, just makes people more active, right? So you'll give some subjects the actual pill, and you'll give some subjects a fake pill, and they won't know which one's which. They won't know if they received the real pill or the fake pill. But the people who get the fake pill, that does nothing, they are the control group. So control group are again essentially the group that doesn't get the actual treatment. So control group would be the group that gets like the placebo, right? The fake pill. And the placebo effect is when somebody who receives the placebo, and again, they don't know they have the placebo, they might be thinking they get the real one. But when they get the placebo, but they pretend or act like they got the real one, like they don't know. So it's psychologically, they're thinking, oh, I just got the pill that makes me more active. So now I'm going to act more active, when they didn't. In reality, they only got the placebo, which does nothing, doesn't make them more active. But they'll act that way because psychologically they thought they got it. So my comparison to this is kind of like if you've seen Harry Potter, Felix Felicis, so the liquid luck potion. If you know what I'm talking about, great. If you don't, let me explain. So there's a part in the series where Harry has this liquid luck, and if he drinks it, then he'll have luck for the rest of the day and whatever he wants to accomplish, right? So he pretends to give Ron the liquid luck so that Ron can perform really well in the upcoming Quidditch game, right? Because Ron's really nervous about it, and he gives him, or he pretends to give him the liquid luck in his drink so that Ron, will do really, really well. So Ron drinks it thinking he took the liquid luck, but he really, really didn't. And he goes out and plays really, really well because, again, he assumed he had taken the liquid luck, but again, he really didn't. So it was all in his imagination. That is the placebo effect. Kind of thinking you maybe got the um, active treatment when you didn't, right? All right, so double blind. A double blind is when neither the subjects nor those who interact with them and measure the response variable know which treatment the subject is receiving. So what that means is like, let's say I, as an experiment conductor, assign certain people a treatment and then other people a placebo, right? I'll know who has a treatment, who has a placebo. But there will be a different group of people who will measure what they're doing, like who will observe what they're doing. So those people who are observing my subjects don't know which subjects have the active treatment, which ones have the placebo. But I'll know that. But the people who are observing my subjects do not know that. So the subjects themselves don't know if they have the active ingredient or the placebo, and the people watching them and observing them don't know who has it either. So then, I would gather the results of their observations and I would look them over, and then I would then be able to see what they recorded and make my conclusions. But double blind is when the subjects don't know what they're taking and the people observing them don't know who has what either. All right. So our first example about confounding variables. In a study of a random sample of 1,739 adults from Nova Scotia, Canada, researchers interviewed each participant and, among other variables, assessed their attitude using a formal psychological survey. It was found that adults who had a more positive attitude were less likely than their peers to have coronary heart disease over a 10-year period. Based on this study, is it reasonable to conclude that a positive attitude causes a decrease in the risk of coronary heart disease in adults in Nova Scotia? Explain your answer. So basically, they're saying they measured people psychologically and said, hey, here's this group of people who have a very positive attitude. And then 10 years down the line, they realized that that group of people were less likely to have heart disease. So their conclusion is, oh, these people with a positive attitude have lower risk of getting heart disease. So the positive attitude must be the reason why they don't have heart disease. And that's not entirely true, right? There might be something else going on that might be the real reason why they don't have heart disease. So for example, maybe this group of people exercise every morning, right? Most people, when they exercise in the morning, they have a pretty good mood the rest of their day. It's one of those things. That's why they do it, right? They do it to stay fit, but also it helps put them in a good mood through the rest of the day, knowing that they've already like accomplished that. So maybe this group of people does exercise a lot, right? And maybe that would be the reason why they have a low risk of heart disease, not because they have a positive attitude. Maybe it's because they're exercising a lot. But we didn't measure that, right? That's a confounding variable. We're assuming that because they have a positive attitude, they have a lower risk of heart disease when it's not really the attitude that's causing that. It's more like their exercise routine, right? Their exercise routine is probably the reason why they're lower risk for heart disease. If that makes sense, right? The exercise routine puts them in a good mood, and then we think that their good attitude is the reason why they are lower risk, but really, again, it's probably the exercise, which is the reason why they have a lower risk. So I'll write that down. So essentially, our answer when it's asking, is it reasonable to conclude that a positive attitude causes a decrease in risk of heart disease? We're going to say no. It is possible that Nova Scotians with more positive attitudes may exercise more often. And that regular exercise decreases the risk of heart disease. There you go. All right, moving on to our next example. Can reducing calorie intake increase the length of one's life? Researchers randomly assigned 46 monkeys. I don't know how to say that type of monkey, but 46 monkeys to a calorie restricted diet group or to a control group that received a standard diet that was monitored to prevent malnutrition. It was found that the control group, or the not the control group, sorry, the calorie restricted group lived longer on average. Explain why it's necessary to include the control group. So basically, again, to summarize it, there's two groups. There's monkeys who are getting a calorie restricted diet, and there's a group that's kind of just getting their normal standard amount, right? And so they're gonna measure those. And they said that they found that the calorie restricted group lived longer. And the question is, why is it necessary to include the control group? Well, let's put it this way. Let me say, the calorie restricted group, let's just make something up, lived for 30 years. Calorie restricted monkeys lived for 30 years. Now, you don't know if that's good or bad because you need to know how long they would live anyways, right? So if then I was able to say, well, the calorie restricted diet monkeys lived for 30 years, but the ones with a standard diet lived for 25, then you know that the calorie restricted diet was an improvement. So you see, we have to have something to compare to, right? We can't just say, oh, they live longer. Longer than what? We don't know what we're comparing it to. So the control group allows us kind of a baseline to compare from. So the control group is, again, just the monkeys with the standard diet, doing their normal thing. And we're seeing how long those monkeys live. But then we give the monkeys a calorie restricted diet and we see if they live longer than that, shorter than that, or about the same as that. And the conclusion is that they lived longer. But we need something to compare it to. We have to know if it's better or worse than the normal amount. So the control group, let's write this down. The control group shows how long monkeys live on average. With a standard diet. This group serves as a baseline. Oop. This group serves as a baseline to determine how much longer monkeys live on average. Oh my goodness. To determine how much longer monkeys with a calorie restricted diet live on average. Right. So again, it's creating a comparison. We can compare with the control group, where we are able to compare standard diet monkeys with this calorie restricted diet monkeys to see which group is living longer and by how much longer. But without two, we can't make a comparison. All right, and then finally, Our last problem says lobster populations in some parts of the world are declining. One solution to this problem is to raise lobsters in hatcheries and then release them into the wild. Growing lobsters as large as possible gives them the best chance of survival when released into the wild. One experiment to determine the best nutrient levels used diets containing two different amounts of protein, 400 or 500 grams per kilogram, each with three different lipid to carbohydrate ratios, low, medium, or high. These diets were compared to a conventional diet of Antarctic krill that was fed to some of the lobsters. Among other variables, researchers measured the growth rates by the length of the carapace. I'm not a lobster expert, but the upper shell section of the lobsters. All right, first thing says it lists the explanatory variables and the number of possible values. Now, the explanatory variables is again the input variable. What the experimenters are doing with the lobsters. What things are they changing? Are they tweaking about their diet? And so there were two things that they were changing. One was the amounts of protein. They're changing the amounts of protein. That is one variable that they are tweaking. And there were two, it says list of possible values for each. There were two possible values because they did either the 400 or the 500. All right. The other variable that they were tweaking was the three different lipid to carbohydrate ratios. So the lipid to carbohydrate ratios was the other thing they were tweaking. And of course, you saw they said there were three of them, three possibilities. Those three were, as it said, low, medium, and high. So there are two things they were tweaking about the diet, the amount of protein they get and the lipid to carbohydrate ratios they had. So the next question is how many treatments were included in the experiment? So if you think about all the possibilities, right, there would be 7 treatments. And this is because the two values for amounts of protein would pair up with the 3 possible values for the lipid to carbohydrate ratios. So we're going to mention this next. It says list 2 of the treatments. I'm just going to go ahead and list all of them for you. But there would be the 400 amount of protein, gram per kilogram protein, paired with low lipid to carbohydrate. There would be the 400 gram per kilogram plus the medium lipid to carbohydrate, and there'd be the 400 protein with the high lipid to carbohydrate. But of course, you would also have the same 3 for the 500 protein. So the 500 protein with the low lipid carbohydrate, the 500 protein with the medium lipid carbohydrate, and then the 500 protein with the high lipid carbohydrate. But that's only 6, so why did I say 7? Because the last treatment would be the control group. So the control group, remember, was the one group that doesn't get any of this stuff. The control group, as it said, was that it says in the problem, these diets were compared to a conventional diet of Antarctic krill. So conventional diets is the 7th treatment group. All right. So I'm kind of answering B and C at the same time there. All right, 7 treatments. Those are all the different treatments to make it easy for you. All right, so that's going to do it. So hopefully that helps. If you have any other questions, just let me know. These are all posted as well. So yeah. All right, I'll see you guys in the next one. Bye for now.